and we're going to multiply these two rational expressions. And if we notice here, they're in quadratic form. I also take a look at the leading terms coefficient. This is 6, this is 3, this is 2, and this is 1. And why is that important? Because I can kind of start thinking of which ones are a little more challenging and which ones are easier to factor. And our goal is to write them in factor form. And when we do that, at the very end, we'll have our final expression look something like this, right? And this is not complete, but this is an idea of where we want to get to. So how do we get there? So let's come back to these guys, and let's label these for our next slide you're going to see. This would be A, this would be B, this would be C, and this would be D, okay? So when I show you the next whiteboard, remember A, B, C, and D, okay? So let's bring these guys in, and like I said before, there's a lot of work here, but they're labeled A, B, C, D. Each of these represent the quadratic from the rational expression we're multiplying. So let's start with the very first one, A. And I kind of already started it for you. Now, how did I get this? I'm going to work backwards here. I know that if I multiply the leading coefficient with the constant, I get -6, and the middle term is -1. So I'm going to write the multiples of 6. 1 times 6, 2 times 3. Well, which pair is going to give me -1? Well, 1 minus 6 is 5, or 6 minus -5, or 6 minus 1 is +5. That's not going to give me my middle term. I still have to check this, even though I'm already thinking, like, this is probably going to be my answer. 2 minus 3, that's going to give me -1. So I'm going to put -3 and +2. And that 2 looks a little bit rude. There we go. Translates over here. These two are 2x, -3x. And I have my leading term, 6x squared, my constant, -1. Now what I do is I go ahead and find my dimensions of my area model, okay? So just to break this down, let's see. This would have to be 2x, and this would have to be 3x. Why? Because this has to be -1. -1 times 3x. The area of this little square is -3x. That checks. 2x times 3x. The area is 6x squared. Therefore, this has to be +1. +1 times 2x is 2x. That's my area. And the area for this is my checkoff. +1 times -1, that gives me -1. I am good. So this checks off. I have my dimensions, which are, and I'll write them here, 3x plus 1 times 2x minus 1. Okay, so the product of my dimensions equals the sum of the area of the parts. Now, let's jump into the next one. This one, okay? Same thing, my leading coefficient is x squared. My constant is -32 because the leading coefficient is actually 1, not x squared, but 1. 1 times -32 is -32. And my middle term is +4. So again, I write the factors that give me 32, or multiples, sorry. Whichever way you want to look at it. 1 times 32, 2 times 16 gives me 32, and 4 times 8 gives me 32. But which group, or which pair, gives me a +4? Well, it looks like this one here is going to work. Now, because 4 is positive when I add it, but when I multiply it's negative, that means one value is negative, one value is positive. It's the only way it's going to work. That means my 8 has to be positive, and my 4 will be negative because 8 minus 4 gives me +4. And then I set this up, right? You can choose where you put the 8x or -4x because the area model will make sure that the dimensions, as you try to figure them out, will coincide or work with the areas, okay? So I start with x times x squared. Now, -4x is my area, so -4x divided by x gives me -4. And here, well, positive 8x divided by x gives me +8. And now, why do I know that's to be true? Because +8 times x gives me +8x. And again, my 8s look very rude. There we go. And just to check and make sure, the product of -4 times positive 8, that's negative 32. That checks off. And so I can erase this and this. And my dimensions will be x minus 4 times x plus 8. All right, erase that. It's out of the way. All right, on to the next one. And this one, same thing. The leading coefficient of my leading term is 3. The constant is positive 8. Notice that I kept the sign. 3 times 8 is positive 24. And if you remember, the middle term is 25. So here are my factors, and I kind of erased the 1. Our multiples, they make up 24. 1 times 24, 2 times 12, 3 times 8, 6 times 4. I have to choose the pair that not only when I multiply, but also if I add those two numbers, it gives me 25. The best one is this one. 1 plus 24 is going to give me 25. So these are out. I have these two values. I put them here, and I got 24x and 1x. Now, 3x times x, that gives me 3x squared. That works great. But when I go here, 24x divided by x, I get 24. I notice that there's no value I can multiply with 24 to get 8, unless I'm multiplying it, dividing it. So that means I have to switch these guys around. Okay? And that's what I meant by it doesn't matter where you put your other two terms, your area model will correct you and guide you to your answer. So then this has to be 3x squared. This would be x. Now 24x divided by 3x, that has to be 8. 8 times 3 is 24, positive. And here, 1x divided by x gives me positive 1. Positive 1 times 8, that gives me positive 8. Yes. And now you see that I have everything in order. So my final dimensions is 3x plus 1 times x plus 8. Okay? The leading term has a coefficient of positive 2. My constant is negative 4. 2 times negative 4 is negative 8. The middle term is positive 7. And now I look at for which group is going to work. The sum of which two numbers gives me 7. Obviously, it has to be 1 and 8. Right? And because the product has to be negative, one's negative, one's positive. And in this case, because this middle term is positive, 8 has to be positive. Negative 1 times positive 8 is still going to give me a negative. I'm good, but when I subtract 1 from 8, I get positive 7. So again, I just do my setup, and then I go through the motions. I think I'm going to go here. And the more you practice, you'll start to recognize before you even start writing down where your dimensions go. This would be negative 1, I believe. Negative 1x divided by x is negative 1. And this must be positive 4. 4 times 2x gives me 8x. Negative 1 times positive 4 gives me negative 4. Checks. So I finally have the last part, 2x minus 1 times x plus 4. Okay, so now that I have everything simplified, I'm going to take these products and write them into my next expression. Wow, a lot of work, huh? And it's going to look something like this. Now I'm going to zoom out and see what it looks like. There we go. Okay, so here is my rational expressions where I've taken each quadratic, factored it, and then rewrote my expression in the form of factors. So we went from this, ta-da, to this. And now I can simplify things before I do anything else. So I notice that this 3x plus 1 divided by 3x plus 1, that gives me 1. And then I'm going to look over here, and I notice that there's nothing here I can simplify. Okay, so then I'm going to rewrite this expression, and it's going to look like this. This is my final expression. Make sure my x looks nicely written. Okay, can I simplify any further? Well, I multiplied numerator times numerator, and I got this, and then I multiplied denominator times denominator. And don't forget that we are still dividing. Okay, still dividing. So again, 2x minus 1 divided by 2x minus 1, that's a giant 1. These two are not identical. Careful, it's plus 4, that's minus 4. Don't let your brain trick you. These are identical. So what am I left with? Well, 1 times this expression times that is going to look something like this. Oops. 1 times 1. Make sure this looks nicer. Well, obviously, 1 times 1 times 1 is 1, so I'm left with my final answer, x minus 4 divided by x plus 4. X cannot equal negative 1/3, right? What did I get negative 1/3? Remember these guys back here? Each of these, if I set them equal to 0, I'll find the real number values that x cannot equal. Okay? Why? Our denominator cannot equal 0 at any point, whether it's from the beginning, during the middle of the process, or towards my final answer. Anytime I choose a value, I can't get 0. So x can't equal negative 8. X can't equal negative 1/3, which I have here. X cannot equal, I believe this to be 1/2. 2 times 1/2 is 1. 1 minus 1 is 0. And x cannot equal negative 4. So those are my real number values. And I'll put it to the side so I don't forget what I have. And negative 4. And this, after all the work, is my final answer. Okay. On the last one, I'm going to cut less of the chatter and just show you the work so you can just follow along. All right. Till next time.